Thank you very much for the introductions. And let me just start sharing my screen.
And then we can start the recording as well.
Yes, awesome. I think we're recording, so we're all good to go. So yeah, like we said, it would be about .NET and about Dockers. Um, so my name is Idan Shatz, and I'm developer advocate here at Ozcode. And we had a series of trying to educate people about Docker. And the reason we are doing that is because what we found out that while Docker is really mainstream technology, a lot of the time when people come from the .NET world, it could be a little bit scary. And that's why what I will try to cover here today is to have some short introduction to Docker. And the idea here is if you know what a VM is, you use the Azure in some form, and you know Visual Studio, then probably it will be good to use Docker. But then we will actually cover a little bit into the details of how Visual Studio actually enable you to do debugging in Docker. So I would really hope that if you just new to Docker or you've been using Docker for a while, you will get value from this talk. And we will then talk about how to debug containers, what are the limitations, and how production debugger could actually help you in this specific scenario. So with that, let's start about what is Docker. So the main idea is if you know what virtual machines are, and probably you know what Docker is as well. And I will try to show what the differences between them so you can take advantage of what Docker provides. So every time you want to run a VM on a machine, then you have the metal, the computer itself, that run the host OS. And if you install a hypervisor, which is basically a small software that allow you to use the features of the CPU itself to create virtualized machines that will run on the same memory and the same hardware as the host OS. Now, each virtual machine would actually host two different things. One is the guest OS. For example, if you're running Windows VM and you want to set up a Linux VM, then you need to load the guest OS into memory as well. Uh, and then you probably would like to run your application. And as you can see here, there is a lot of boxes here that have guest OS loaded into memory. And that is probably the main problem with virtual machine, that every time you want to boot one, you actually need to boot the entire OS into memory. Now, and then we just have a lot of duplications here. And that is what Docker, I think the main idea of Docker that really come to help. Because what we really want is just we want to run those applications, but on different different virtual operating systems. And we already have the host OS, which is know how to open files, create processes, open sockets, and all the things that we need in order to run our program. So what Docker decided to do is basically replacing the hypervisor with Docker Engine. And instead of actually trying to load the entire operating system and implement file access all over again, it's basically a small channel to actually proxy the request from the virtual machine into the host OS to run everything with some security built on top. But that really gives us the ability to really minimize the amount of space that we need to mimic that we have a full OS inside the virtual machines. And that basically allows us to reduce the size of the OS. Now, we try to put a little bit in scale here the size of the OS inside each Docker image. And as you can see here, Linux containers are usually small. Alpine is very tiny container, while the Windows OS is big. And I would like to address that. So there is actually, if you are a .NET developer, you have two options when it comes to use um, Docker images. One of them is the Linux container, and the other one is Windows containers, which basically sounds what they are. It's basically what type of operating system you want inside your container image. Linux containers are smaller and Windows container are larger, but there is other features that you want to consider. When do you need to choose which? So if you have a legacy application or your application is using the .NET framework, well, the .NET framework depends on the Windows operating system. So probably that will be the route that you will choose if you want to run your .NET framework application inside the Docker. Now you need to know they are large. They 2 GB per container image. There is some optimization regarding memory, but they're big. And you will probably want to go this route if you want to run legacy applications inside Docker. And that will give you a Windows operating system, and you can use all the nice and cool features of the .NET framework. For .NET Core, you have a different option, and that is to use a Linux container, which are smaller. So for example, the ASP.NET on Ubuntu is around 200 megabytes, which is a big difference as if we compare it to Windows containers. And I think that will be the future of where .NET will actually evolve down the line, because now if you run .NET Core, it's basically agnostics. If you want to run on Windows, it's okay. If you want to run Linux, it's okay as well. Jason, if you monitor the chat, then please let me know if there is any questions or something is unclear so far.
Sounds good. I will.
Awesome. Thank you. So now that we understand what is Docker Engine, that is basically the software that run those images, those Docker containers, let's talk about what Docker image is, because that is another term that gets used a lot. Um, and this is very similar to what a VM image is. So let's describe what a VM image is in the first place. If you want to boot virtual machine, you need to start with a VM image. And just one moment, of course, my kid just decided to enter.
When we get back, feel free to ask any questions in the chat, and we'll raise them up. So it's one of the joys of virtual meetings. We have so.
Really sorry about that.
No
That
worries.
something had to happen, right?
Yes.
Yes. So yeah, my kid was in a crisis. He can't find his iPad. So after we resolve that, let's continue. So when you need to put a VM image, um, you need to start, when you need to want to put a VM, you need to start from an image. That would basically be the initial boot image that you start. And then you start running your image to do all kind of modification. And then at some point you want to save the current state. So you pause the virtual machine and create a standard checkpoint. Usually that is a term that would be used, which saves two things. It saves a new VM image, which basically is a disk, how the file has changed, and also the memory itself. So basically it's like hibernating a computer. Now, the new VM image, probably there is not so many changes. The operating system probably didn't change a lot. Something did change. So that's why usually we just store the delta between the base image to the second image. And that goes also from the second one. For the standard check, you can do another one and you send a new delta. But there is another thing that you can do, and that is you can actually shut down the VM and only save the image basically after the machine finish its cycle. And that really help when you talk about production checkpoint, when you want to make sure that the state is um, would not change and there won't be any issues between already running processes and updates and things like that. Now, two main things here that I want to just to mention, that if you look at a VM, you will start with a base image, And then every checkpoint will just add more local changes to the local disk. And then the running VM would actually have what they call the current state, which also save the changes that actually happen in while the VM is running, and also the memory itself, what processes are running and things like that. And if you compare it to Docker image, it's really the same thing. Um, every Docker would start with a base image. The base image would basically be like we talked about before, how do we proxy all the system calls from the guest OS to the host OS? And then several Docker images that will basically add more features. Install.NET, install ASP.NET, and things like that. And the last layer, which is only the read-write layer, all the other one are read-only, that would basically be the changes that happen while you run your container. Now, VM actually mimic the entire hard drive, but Docker actually just use the hosting OS file system. So instead of storing all the disk and all the pages inside the disk, you just need to store what files were changed. So what we gain out of that is that we can actually reduce a lot the size of those checkpoints. Moreover, there is another cool feature in terms of memory usage because all the based images are read-only. If you run two Dockers that using the same images, we can actually save a lot of memory, but reusing the base Docker images between all the Dockers. So, any questions so far from the
No questions yet.
no question? Yes, awesome. So, if I think the next thing that we can do is actually look at some Visual Studio stuff. Um, so if you have, for example, here I have an example, and we'll talk more what this example actually does when we will go and debug it. But the service A is a basic ASP.NET .NET Core 3.1 project. And if you want to run it using Docker, what you can do is just right click, add Docker support. And then you can decide if you want to have a Linux and Windows support, like we talked about it. And that will basically generate a Docker file for you, and which is looks something like that. Now, this Docker file has been modified for the demonstration purposes, but let's go back to the presentation to talk about what this Docker file is all about. The Docker file itself, that is an example for actually Docker, not 3.1, but 2.2 .NET Core. It's a set of instructions that really help you create those Docker images, which I think is a very cool feature because it's really enable you to automate how you build your microservices, and also it's allow you to then publish and versioning those images. Now, but let's try to figure out how that actually works. Now, for .NET Developer, because Visual Studio have this Docker support, most of the Docker files for .NET are extremely boring, and probably you would not even need to touch them at the beginning. But let's just dive in to understand what is going on. So the first line here is from, and there is some image name that basically define what is the base image that we want to do. Then this is actually say, let's copy files from the local file system inside the Docker image. And after we copy that, let's create a new image out of that. So every line here would actually create a new image file until the last one. Now, this is an awesome example that we ask it to run .NET Restore on the project that will basically install all the NuGet packages from this project. And um, and after we finish installing the NuGet package, create a new image so we can start from there. And with that, I think if there is no more questions, I think we will go and start diving into how we debugging some Docker containers.
No questions yet.
No question is awesome. So this is a project that we will play around here to figure out what is going on and how can we debug things. Um, and the project itself is about uh, superhero night school, and there is several services here, and you can see they all are running, and everything is awesome. And there is a list of courses, and what we do here, we need to assign rooms to each course. So if we go here, we can see that they need a projector and a Wi-Fi for each room, and they need 300 people. So we can assign this big room for them, and then maybe assign a different room as well, and maybe assign this one as well. But that is very tedious. So we have an automatic function to just schedule that, and it's find all the matching rooms. Now, with that, we would like now to debug to see how we do the health checks here that the system is working. Now, the problem is it's no longer running usual that you have your IDE, the Visual Studio, and you want to debug a C# application. If they're running on the same OS, then it's pretty easy. You can use a debugging API. However, if you need to run it inside a Docker, you're actually talking about remote debugging. So let's see what Visual Studio offer for us about remote debugging. So go to debug, attach processes, and the default will basically, as you can see, list all the processes that running on my machine, but you can also use Docker Windows and Docker Linux. So we will choose Docker Linux and we will click find. Now, as you can see, we're running that on a local machine, but you can run that on remote machines as well. But the demo that I'm running right now, actually running inside Docker Compose on my local machine. So we can see here, this is all the Docker images that is currently running. And we want to connect to service A. So we did OK. And as you can see, it's actually fine that there is one process running, which is the .NET Service A DLL. Basically, how do we run the .NET Core application? Usually, you will need to select how you want to manage, what do you want to debug, and we will choose managed. And then we can click on that process and click attach. Now, while it's launching the debugger, I will actually open that and let's clear it and run some Docker commands. So Docker PS would basically show me all the Dockers that are currently running. And we would then figure out as soon as now you can see that Visual Studio enter the debugging mode, but let's see what happened behind the scene, how that actually happens. So we will do Docker top, which show us all the processes that are running inside our Docker. So if we do service, sorry, the name Docker service, I would actually ask for service B to show you what's usually running when um, on a Docker without debugger attached. You see that there is only one process running .NET service B.dll. However, if you're running on you ask it to list all the processes running on service A right now, you can see we have our process, but there is another bunch of stuff that currently are running here. We will chat a little bit what they are specifically, but this is what happened when you ask Visual Studio to connect to a Docker. It will basically run several commands to install VS Debug and connect VS Debug to the running process that you want to debug. So let's actually see that in happen. There is this get stat function, and we will put a breakpoint here. And if we will go to this UI, you can see start that it's now waiting here. And we actually got a breakpoint. And now we can actually go and see everything like we use debug. We can do step through, step into, and do whatever you want in terms of how you debug it normally. So let's continue with that. And now everything is okay. So let's summarize what we see so far. So if you want to debug container inside Visual Studio, basically what you're going to do, or what Visual Studio will do for you, it will install VS Debug on your container and connect it through the STDIO and start communicate through that to debug your application. Any questions so far about that?
No,
We all good?
we're good.
Awesome. So another cool feature that we that Visual Studio allow us, and I will need for that to stop everything. And of course, yeah, we didn't stop the debug process, so he would complain about that for sure. Awesome. So you can also add, and that is part of what I was using, you can show container orchestrator support. And that will basically create a Docker compose file for you that would have all the process that you want to run already been orchestrated by the Docker compose command.
We
And
do have
then
a
you
question
can, yeah,
if you
sure.
have time. So I have a question about, will it remove those installs from the container once the debugger stopped, the things that Visual Studio added?
Yeah, exactly. So if you recall, when we do a Docker file, we actually build an image. And when we do Docker run, we actually use that image as the booting image to start running from. So all the commands that will run while the Docker is alive, okay, would be added to only to that running instant of the Docker. As soon as that running instant of the Docker ends or terminates, then all the modification will actually be removed. So it's not part of the Docker build process. So all the modification that Visual Studio does would remove as soon as the Docker exits. Awesome. So if you have Docker Compose, you can also do Docker Play here, and that will then start running those containers and would open all of them in debug mode. Hopefully. um, yeah, we actually start running everything here. Now, usually Docker build take much longer time, but in this example, and it will actually go and start the process, but in this example, it started extremely fast. And that is very important because when you use the Docker Compose option, and again, you can go now everywhere, put a breakpoint, and I think just hit that specific breakpoint. Oh yeah, we already hit that breakpoint. So as you can see here, now everything is kind of frozen because we are stopping that process. And if we continue, we actually can see that everything is running. Now, yeah, and we hit that again. So let's remove that so we can actually continue do stuff. So how did Docker Compose actually work and how that it's boost your productivity by running things faster? Now, this is really, really interesting because if we do another Docker PS here, there is several things here. You can see here that the images were service auth, service A, service UI, and now there are service UI.dev.dev.dev.dev. And the command that it's running is actually tail minus F, which basically tell it, just keep this container alive. And if we will do Docker top for service A at the moment, you will see that it's very similar to what we have when we have running in debug here, that it's basically running, it's running the um, the VS debug and the .NET process. The main differences here is when you use that Docker, what Visual Studio does for you, it's actually build all the images in the host OS and then mount all the already built artifacts of .NET inside the Docker. So there is no really Docker build, and the Docker images that you use is just a basic .NET image. So a lot of settings that you have in your Docker Compose file would actually be would not be present. So that is something that I think you should be aware of. But again, most of the Docker files that you will have when using .NET will be the same. So probably it will work fine. So, and with that, we would uh, stop this one. And the most useful command ever is docker kill docker ps minus q. That will basically kill all the existing Dockers. And we would boot what we have before with Docker Compose up, and that will start running. And with that, let's talk about the limitations of debugging a container. Um, when you're debugging a container, as we saw, the container itself is still running. It's not like when you debug a process that you make the process froze. The container itself is running. What is actually frozen is your application inside the container. Now, why that is a problem? Because outside of the container, it's look like we have a running container with an application that become unresponsive. And that actually start causing all kind of interesting issues. One of them is if your container is actually being used by other containers, they will start and they will continue send requests in their normal operations. And we saw that in this example, that when we actually start debugging, we see this running uh, progress bar that say, yeah, we're still waiting. We didn't get the right health check response because that process is currently frozen, which basically will at some point will cause that container, the other microservices, to be frozen. And that is what we call cascading events. So while you depose one container because you want to debug it, that could actually lead to a catastrophic things inside the cluster and start creating all kind of other uh, unwanted side effects. Another interesting thing, usually in microservices, you want to run each service several times in several instances. Now, if you debug one of them and you have a orchestrator that try to figure out which container need to get what traffic, after a while, the health checks would start failing and none of the traffic will then continue to go to your container that you're trying to debug, which is a problem that you need to consider if you're trying to debug your container with some other uh, orchestrators involved. So just to try to summarize what the limits that you need to consider when you try to debug a container um, is when you're freezing a container to debug it with Visual Studio or some other tools, all the other clusters still running, and that will start leading to all kind of interesting side effects, from failing health checks to the container being recycled because it's not responsive. And even correlating events across multi-services could actually start causing issues because there will be fail request and we'll start sending the request to other things. Any questions so far? I, for some reason, don't see the chat, so.
Oh, sorry, I was on mute. We have a couple questions here. So there was a question about, did you mean a dependency from the previous slide? I, um, I don't know if you can elaborate on that one, but
Yeah, I'm not sure which slide we are talking about, so
okay. Well,
if there
the
is
other
a
question I have
clarification that, yeah.
is, what is the most differences between Docker Compose debug and attaching Docker processes with Visual Studio? What's different between those?
What the difference between those two? So in terms of actually how the debug works, they are exactly the same. Where it's different is when you do Docker Compose by yourself, like I saw, like I show here, you do Docker Compose with the right Docker Compose files and boot them. It would actually use all the Docker build files, and that would basically be the Docker images that you will push into production. When you do the Docker Compose debug mode options inside Visual Studio, it would not load those final built images. It will basically start from empty images and then mount the locally built artifacts from your host OS into those Dockers to basically speed up and ignore the Docker build process. So while it's very convenient to boot all the processes using that, all the microservices and all the Docker images automatically for you and attach to all of them at the same time, that basically the benefit of the Docker Compose inside Visual Studio, you need to be aware that you're not running the final images that will actually go to production.
Okay. And there's a thank you for that. I do have clarification from the previous question. So in the last slide, the containers were pointing to the right, and being not familiar with Docker, you can have a base image as a dependency to get another container working from that base image if you want, is the question.
So I'm not sure that I really fully understand the questions. So I think there is two type of questions there, and I will just answer both.
Thanks.
So
Sorry.
what I meant here is that you have one container with this purplish image and a different container, a different microservices from a totally different image that is basically calling that service to do something. That is what this diagram is supposed to mean. So those are specific different images, different services. However, when you use Docker Compose, you can actually run the same image multiple times. And that's very useful, specifically if you have a large cluster. You have a service and you want it to be more robust. You want it to be able to handle more requests. So basically, you run the same image multiple times, and that will create the different instances. So I hope I answered the right questions, but maybe he didn't. So if there is
And
another clarification, let me know.
I imagine the orchestrator would just then orchestrate which one requests would go to when it's running.
Exactly, exactly. That is basically the role of that unit at the top, is basically do load balancing between all the requests. And that's what Kubernetes usually used for, what Docker Compose if you do it locally.
All right. I
Awesome.
think that answered it.
Great. So
You have, sorry, you have two more questions. How long do you have before health check fails cause container to reset?
that would be basically based on how your orchestrator is configured. So
Okay.
yeah.
Can a Docker workflow be configured to support hot reloading if used during development?
Yes, you can do hot reloading. Basically, it would be a different. You would need to have a little bit to play with your Docker file. Basically, and the Docker Compose. The idea of that is you basically mount the source file that you have inside the Docker. So when they change, it will actually go and update the Docker images inside the Docker that will cause a hot reload. Now, it really depends on what type of front end you're creating. That will basically have different Docker files to set that up.
Great.
Awesome. Now, um, just to talk about how we can overcome those limitations in when we try to debug multiple containers. And the basic here is that we really do intrusive debugging. And what we mean by that, when we debug, we try to do two different operations. We try to extract information from the system. So basically, when we hover a mouse over a variable or get the stack trace of all the current threads, extract information from the process, and then we try to reason about it. Why do we think that is the bug? Where is the issue here? And the issue here is that one happened in computer speed, while the other one happened in human speed. And I think there is a better way to do it, and just is what we call non-intrusive debugging. And that is, let's extract the information, and then let's reason about it in the past. And that is really the basic idea that we're trying to do, is try to understand the system behavior without the need to freeze it. So we can actually do it. Now, non-intrusive debugging been here for a while, and generation 0 is basically console.writeLine and just log to the console everything that happens. And that is, we all did it when on our first program. So we know what that means. Usually you do it when you don't have a debugger, right? That is another option to do it. Gen 1 is actually creating what we call structural logs. So now we start not just creating messages, but we actually start passing arguments. And with tools like Serilog or Log4net that actually allow you to create those structural logs, you can actually stream those logs into solutions like Logs.io, Datadog, Elasticsearch. And now you can actually search based on the age, based on the customer name and stuff like that. So that really allows you to have better ideas what actually happens. And again, that go back to the non-intrusive debugging. You just log all the information that you think you need, and then go and try to read the logs and find what the issue was. Another cool thing that actually now start is the open tracing, which basically every time there is an HTTP request, we actually create a GUID to track it. And then all the requests that go after that to a different services would use the same correlation ID or the same transaction ID. And now you can actually put back together an entire flow of operation that happens. Now, the main problem of all those techniques, and that is, I think, the ultimate paradox here, that if you knew what you want to log in order to solve a bug, you already solved the bug because you know what you want to debug it. And that is the main issue, that those usually what you see in those examples is that you're trying to solve a bug by adding a few more lines of logs. See if you can figure out the mystery. And if not, you will just add more and more and more until you have all the information that you need. And we believe it's time for Gen 3, and that is production debugger. So with that, let's just go and see what we can do with it. So we will go to courses here. We have everything is running. And we also have the production debugger here connected to those agents. If you will check the production debugger later, you will see how you can connect the production debugger to your Docker images. It's few lines that you need to add to the Docker file, and you're up and running. And we will see that if we schedule this one, everything work. If we schedule this one, everything work. But if we schedule this one, something happened. There was a bug somewhere. And if we now go to the production debugger and ask it to refresh the information, you can see that we have two different exceptions that been collected. Now you can see that the status here is capturing, and that is important because it will help me explain what the production debugger do for you when you have an exception inside your .NET application. The first time the exception happened, the agent would actually collect the entire stack flow of that exception and would add instrumentation in real time only to that specific code path to be able to record everything that would happen next time that exception happened. So we will go back here and do another schedule. And let's do refresh again. And now you can see all the states are captured. Now we can go to the debug here, and we can actually see the root of the problem here. You can see we get the code um, for the function that actually failed. And you can also see that the problem was that features was null, and we do feature.split, so null reference as a chord, and that basically what start failing everything. Now, if we will go back here and go to the service A, here we can actually see more information. First, it was a little bit deeper inside. And also we can see that that was the original call that happened. We need to resolve schedule for hand 001 course. And that sent the message to service B when all the rooms are available, but that actually failed. So you can actually get correlation between two different operations. Now, it's a little bit hard for me to understand what is going on, so I would actually request it to do full-time capture and what that is all about. And as you can see here, it says that it's capturing full-time travel. After we capture the second exception and we got all the information, all the code, the local variables, we remove all the instrumentation. But you can ask it, information. Can you record a full-time travel? So record everything that happened from the beginning of the HTTP request until when the exception happened. And in order to actually record that, we need to create the third exception. Then we will go back to our screen, do a refresh. Now you see it's fully captured. And now when I do debug, you see much more. You can see here that we have code highlighting that actually show you what happened. And we can see that features was an empty list. So we get these excluded rooms. This if statement, excluded room is not null, return false. Or it's not null, so because it's null, then it's false. So we didn't get into this branch. And here, this this expression evaluate to true, so we didn't even run the second expression. It was skipped because this is lazy evaluation, and then we see these exceptions. And you can go back and back and back, and you can see um, for every function here, you can get all the local variables. And that really come to solve the problem because we don't know what you will want, what you will need in order to resolve these issues. So we just record everything for you. And you can actually see for every request, you can get all the headers and the response. You can get everything for you, even all the log messages that actually happen around that time. Any questions around the first thing of how you debug exception using production debugger?
No questions out there.
No questions so far. Another interest. Awesome. Then let's go up to the next feature, trace points. Now, some of the problems that we have not ended up in an exception, but they ended up in some weird state. Like when we try to schedule this room, it said that it's assigned to rooms, but no student were scheduled. Something is not right. So let's try to debug that in a way that is not intrusive. So for that, we created trace points. Trace points is like breaking points, but non-breaking breaking points. And in order to do that, you need to create a new session. So let's call it debug session number 1. And we're not sure where the problem is. So maybe it's in courses controller, courses. And if I know how to type, that would be much easier. And you can see the entire code appear here. Now, I haven't mentioned that where the code is coming from. When you need to install the agent, there is no need to change your build settings, attach PDB files, or connect to source control. What you see here is the decompiled code that you have in production, or in that example, in my local machine. So that really makes setup extremely easy. So we will put a new trace point here. We found new schedule for course. And as you can see, I use these curly brackets to actually reference local variables that we have here. Awesome. Maybe the problem that we didn't find any room. We didn't find any room. And let's also see that we actually find some rooms. We found a room, room 2. But maybe the problem was actually in the rooms controller. Maybe we didn't get any available room. So let's, and with features. So we will also know which feature they required, like we saw before. Now we created all those trace points, and now we can actually ask the agent to start recording. And now we can go here and do a schedule. And as you can see, events start appearing at the bottom. So let's just go to the last event. And we can see that this was the new schedule. We can actually click it. And we can see that lecture room was 0, but practice room, there was 2 rooms here. So probably we know that we were able to find, where is room number 2? Here, we were able to find rooms for practice, but not for lectures. So if we go here, we can actually try to figure out what is going on. So we have here a list of all the available rooms that can still be assigned. So there is room here with max capacity of 10. So we know that the problem what we didn't find any rooms is that for some reason we weren't able to find an optimal room. And the reason for that is because the desired capacity is 20. So we are looking for a room with 20 people, but the maximum capacity that we have available is 10. So probably the right thing was actually to use the non-optimal room, but here the logic was flawed and it didn't assign anything. So I hope with the demo you can get a sense of how you can actually debug things in production, if they are Docker or not Docker, using the production debugger without getting into all the weird side effects of pausing containers while running. And with that, I think we are done. So I think it would be just a good time for questions. And I will try to find the Q&A as well. So.
Sure. All right. If you have any questions, feel free to type them in and we'll answer them. Here we have one. How does the agent get installed on a production container?
Awesome. So you basically need to modify your Docker build. And the agent is get added by extracting a zip file, basically with all the information, all the executable of the agent, and then setting up some environment variables that will allow the agent to be loaded into your process using the .NET Profiling API. And so yeah, basically it's basically adding several files into your Docker image and sets some environment variables, and you're up and running.
Okay, and there's a Q&A as well. Do the agents install as part of an image, and how much overhead is there?
Yeah. Yes, so the agent is part of the image. That you got that right. In terms of overhead, so it's around a few megabytes. If I recall correctly, it's around like 10 megabytes, but don't quote me on that. But that is more or less um, the size. And in terms of memory footprint and CPU footprint is marginal. Again, few megabytes of memory will be consumed by the agent inside your process, and the agent is smart enough to monitor its CPU usage. So if you have tons of exceptions and we're trying to instrument a lot of code, the agent will figure out that if it's past the CPU threshold, which is 3%, and if it does, it will basically start shut down instrumentation code for you. So it will return to the normal performance that you see before.
Okay, and there's a question about, will the agent work with VMware, Tanzu, Kubernetes grid?
My assumption is yes. I would love to get back to you to see if there is something special in that regard. But basically, if you were able to run your Docker image locally, it will work on Kubernetes grid as well. One thing that I would need to mention is if you have Kubernetes grid, you will need to make sure that the agent can actually communicate outside to the uh, production debugger server. Now, so that would probably, maybe there will be some configuration that you need to do to make sure that you get that.
So where's that? It's the production server services that you guys provide. Is that where you connect to?
So you have two options here. You can use our SaaS platform. So that would be the easiest way to get started. But we also offer on-prem solutions. So you can have your production debugger locally, and that's useful for uh, if you have security constraints or privacy constraints that you can't share, you can't emit any information outside of your network. Now, all the information that gets from our agent to our SaaS platform, there is a built-in PII reduction features, so it's all been reducted. But if you need more advanced security measures, then on-prem solution probably would be the right thing for you.
Any others?
I see there is switching between Windows and Linux containers in the taskbar. It's so message was that as when you run Docker agent on Windows, you need to decide if you want to run Docker Windows container or Docker Linux containers, and you need to switch between them. It was a pain point, but lately it's become not a friction point. It will take a few seconds, but works great.
All right. Well, thank you very much. This is very informative. I appreciate your talk.
Thank you very much for having me.
Awesome. Stay tuned for next month. Have a great evening.
Bye-bye, everybody.
Goodbye.